questions 1 through 10 on the 2002 grade 12 AMC 12A. Compute the sum of all the roots of that equation. So we have 2x plus 3 times x minus 4 plus 2x plus 3 times x minus 6 all equals 0. So if you factor out a 2x plus 3, you will get x minus 4 plus x minus 6, like that. And therefore, you will get 2x plus 3 times 2x minus 10. And this is a form in which you can easily figure out the roots. So x is equal to either negative 3 over 2 or 5. And they want the sum of those roots. So minus 3 over 2 plus 5, minus 3 over 2 plus 10 over 2, that is 7 over 2. So the answer to number 1 is A. Cindy was asked by her teacher to subtract 3 from a certain number and then divide the result by 9. Instead, she subtracted 9 and then divided the result by 3, giving an answer of 43. What would her answer have been had she worked the problem correctly? So let's say she starts with the number. Let's let x represent that number. And she was told to subtract 3 and then divide by 9. But instead, she took the number and subtracted 9 and then divided by 3, and that gave her an answer of 43. So we can use this equation to figure out x. So x minus 9 is 3 times 43, which is 129, and therefore x is equal to 138. And now we can use this to figure out the answer that she should have gotten if she had done the problem correctly. So it would have been 138 minus 3 over 9, which is 135 over 9, which is equal to 15. So that is the correct answer that she would have gotten. So 2, the answer is A. According to the standard convention for exponentiation, 2 to the power of 2 to the power of 2 to the power of 2 equals 65,536. If the order in which the exponentiations are performed is changed, how many other values are possible? All right, let's see what we get. So we got 2, 2, 2, and 2. So one way of doing this, of course, is just to say 2 to the power of 2, and then I'll use that. 2 to the power of 2 is 4, like that. I'm just doing it in a different order. And this will give you 2 as the base. 2 to the power of 4 is 16, and 2 to the power of 16 is 65,536, right? So that's one order, and we got the same result. So let's try another way. 2, 2, 2, 2, like that. Let's make that and that separate. So we have 2 to the power of 2, and then 2 to the power of 2, like that. So 2 to the power of 2, of course, is 4, all to the power of 2 to the power of 2, which is 4 again. If we do it that way, we get 4 to the power of 4, which is 256. So we get a slightly different answer, and that's what they're looking for. Let's see if we can do it in any other way. 2, 2, 2, 2 is where we start from. Let's see, how about if we do the middle numbers, like these ones, like that. So then we'll have 2, this in the brackets becomes 4 and 2, and then this is going to be 4 to the power of 2, which is 16, and again we'll get 6, 5, 5, 3, 6. So based on all these different orders, the only one that's different I got was 256. So there's only one other value that's possible if you change the order of the way you perform the exponents. So the answer for number 3 is B. Find the degree measure of an angle whose complement is 25% of its supplement. So a quick review. Two angles are known to be complementary if they add up to 90. All right? So for example, 30 and 60, those are angles that are complements. Okay? And now you have two angles are supplements if they add to 180. So for example, 110 and 70. Okay? So they're saying you have a angle, let's say it's x, and its complement is 25% of its supplement. So first of all, what is its complement? Two angles are complements if they add up to 90. So the complement of x is 90 minus x. All right? So if you add them together, they would equal 90. Now let's talk about supplement. The angle is x. What is its supplement? Well, supplements are two angles that add up to 180. So the supplement of x would be 180 minus x. Supplement. All right, so I hope that makes perfect sense. And they're saying that this complement is 25% of its supplement. So the complement, which is 90 minus x, is 25% of its supplement, 180 minus x, like that. And we have to figure out the angle, okay? So that shouldn't be a problem. 90 minus x, you want to use a fraction, let's say use a quarter. 180 minus x, like that. So we have 90 minus x is equal to 180 divided by 4 is 45, and then we get x over 4. So bring the numbers over to one side and bring the x's over, so you get x minus 4. So 45 is equal to 3x over 4. So cross multiply and you get 4 times 45, which is 180, is 3x, and therefore x is equal to 60. So the answer is B for number 4. Each of the small circles in the figure has a radius of 1. The innermost circle is tangent to the 6 circles that surround it, and each of those circles is tangent to the large circle and to its small circle neighbors. Find the area of the shaded region. So the first thing I'm going to do is draw a line that connects the centers of the 3 small circles like that. And that blue line that I drew is basically the diameter of the large circle. The diameter of the large circle, dl. And we know that the small circles have a radius of 1. So if you look at that diagram, if the radius is 1, that full blue line will have a value of 6, correct? Because each circle has a diameter of 2, because the radius is 1. So if the diameter of the large circle is 6, the radius of the large circle will be 3. And the radius of the small circles, RS, is 1. That's what the question tells you. So how do we find the area of the shaded region? It's basically the entire circle, the big one, pi RL squared, minus all the small circles that are in white. So how many are there? 7, right? 1, 2, 3, 4, 5, 6, 7, right? So 7 of those small circles. So pi RS squared, like that. And that should give you the area of the shaded region. So pi 3 squared minus 7 pi 1 squared. So this becomes 9 pi minus 7 pi, and that is 2 pi. So 5, the answer is C. For how many positive integers m does there exist at least one positive integer n such that m times n is less than or equal to m plus n? Okay, m times n is less than or equal to m plus n. So we can make a table, m, n, m times n, and m plus n. All right? So let's see what we get. Let's start with 1 and 1. 1, 1. That means that m times n is 1, m plus n is 2. All right, does that fulfill our equality? And the answer is yes. m times n is less than m plus n. Let's keep going. Let's say m is 2 and n is 1. This becomes 2, this becomes 3. If n is 3 and n is 1, this becomes 3, this becomes 4. So it looks like we're getting quite a few here. And the reason is because for every m, you can always choose n equals to 1. So therefore, you would have m times n, which is 1, which would be less than m plus 1. That means m is less than or equal to m plus 1. And this is always true because m is a positive integer. Correct? So basically for any m, if you choose n equal to 1, this will always be true. So there's infinitely many m's, and therefore the answer is E. If an arc of 45 degrees on a circle A has the same length as an arc of 30 degrees on circle B, then the ratio of the area of circle A to circle B is. So let's draw two circles. We got one circle and we got another circle like that. And basically what they're saying in this question is that you have an arc on circle A that's about 45 degrees, so approximately like that. And you have an arc on circle B that is approximately 30 degrees, so about there. And these two arcs, circle A and circle B, have the same length. So this is the same as that. It's the same if you calculate the distance. All right? So we can use the fact that this is 45 degrees and this is 30 degrees and get a relationship between first the radius and then the areas. So in the first circle, we know that 45 degrees over 360 degrees is basically multiplied by the full circumference. So the full circumference of a circle is pi times diameter, and pi times diameter is 2 times the radius. So I'll write radius of A. And this is equal to this segment right here. So arc A. All right? You take the ratio of the angle to the full all the way around is 360 degrees. And you multiply it by the circumference. Circumference is equal to pi d. And d is equal to 2r. And that's exactly what I put in there. RA representing the radius of circle A. And that's arc A. And in a very similar way, 30 over 360 multiplied by pi d, which is pi 2rb, is equal to arc of B. This guy right here. And they tell you that these two arcs are the same. So we can set these equal to each other. 45 over 360 pi 2RA is equal to 30 over 360 pi 2RB, like that. So this becomes 1 over 8, and the 2 pi's cancel on both sides, so we just have RA, and this number becomes 1 over 12, and we have RB, like that. So RA is basically 8 over 12 RB, which is also, if you divide by 4, it'll be 2 over 3. So there you go. We have a ratio between the two radii, and now we can find the ratio of the areas. Area of circle A over area of circle B. So the area of circle A, of course, will be pi RA squared, and the area of circle B is pi RB squared. So pi RA is basically 2 over 3 RB squared. all over pi rb squared, like that. So the pi's cancels, and that will give you 2/3 squared is 4 over 9 rb squared, all over rb squared. So the rb squared is cancel, and all you're left with is 4 over 9. And that is our ratio. So the answer for number 7 would be 4 over 9, which is A. Betsy designed a flag using blue triangles, small white squares, and a red center square as shown. Let B be the total area of the blue triangles, and W the total area of the white squares, and R the area of the red square. Which of the following is correct? So let's start with the red square. This guy right in there. So they tell you that R is the area of the red square. Now they don't give us any values, so I will create values. From there to there I'll say is 1, and from there to there 1, and therefore that is 1, and that is 1. So this is essentially a 2 by 2 square, which has an area of 4. So R is equal to 4. Now let's turn our attention to the blue. Blue is basically the triangles that they have shown in gray. So I will draw one such triangle like that over here on the side, like this. And if you notice, the one right below it is the same one. And two triangles together will form a square. And the square will essentially look like, if you put them on top of each other, the square will be like this. So in order to find the area of the square, we have to find the area of the side right here. Well, the way it's drawn, this is 1 based on my labeling, that line that cuts through the, diagonal. So if that's 1, then we can figure out that from here to here, half of it, from here to here, or from here to here, is a half. Correct? So if the diagonal is 1, then half of the diagonal is a half. So therefore, if you figure out the area of, say, one of these triangles, which is, say, like that right there, the area would be 1/2 base, which is from there to there, is 1, times height, which is a half, and therefore this is a quarter for the triangle. And therefore the square, which is essentially 2 of those triangles, the square will be a half. Okay? So we have to figure out how many blue triangles are there. Well, these triangles, there's 24 of them. 24 of those triangles. So since 2 triangles make up a square, there's 12 squares. And each square has an area of a half. So the total area of the blues is 12 times a half, which is 6. So B is equal to 6. Okay? And then the white is very similar. The whites look like that, right? And those are very similar to the blues in that each white square is essentially 2 triangles, and each triangle has an area of a half. So how many white squares do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 of them, and each of those squares has an area of a half. So that's 6. So that means W is equal to 6. So R is 4, B is 6, W is 6. Now let's look at the answer choices. A says B is equal to W. Well, B is 6, W is 6, and that is correct. So the answer for number 8 is A. Jamal wants to store 30 computer files on a floppy disk, each of which has a capacity of 1.44 megabytes. 3 of his files require 0.8 MB of memory each. 12 more require 0.7 MB each, and the remaining 15 require 0.4 MB each. No file can be split between floppy disks. What is the minimal number of floppy disks that will hold all the files? So he has 3 files that are 0.8 MB. He has 12 that are 0.7 MB. And he has 15 files that are 0.4 MB. And the maximum capacity of a floppy disk is 1.44. So let's see, he can take these ones, 0.8 each, and add them to these ones, 0.4. One file that's 0.8 and one file that's 0.4 would be a total of 1.2. And can he fit that on a floppy? Yes, he can. So how many times will we do that? Well, we'll do it for all 3 of these. So all 3 of these with 3 of these. So that would mean 3 floppy disks. So we've taken care of all of this. Now we've used 3 of these guys. So that means there's not 15 anymore, there's 12. Okay? So now we turn our attention to the files that are 0.7. If we put 2 of them on one floppy, it would take up 1.4. And will that fit? Yes, it will. So since there's 12 and you put 2 on each, there's 6 floppies that you need for that. So now we've taken care of those guys. Now we just have 12 files left with each of them being 0.4. And what you can do is you can put 3 of them on one floppy like this. And that would mean 1.2. So that would essentially mean that you need an additional 12 divided by 3, which is 4 floppy disks. And if you do that, you'll take care of all of those. So how many floppy disks do we have in total? With 3 plus 6 plus 4, we have 13. And that is the minimal number. So 9, the answer is B. Sarah pours 4 ounces of coffee into an 8-ounce cup and 4 ounces of cream into a second cup of the same size. She then transfers half the coffee from the first cup to the second, and after stirring thoroughly, transfers half the liquid in the second cup back to the first. What fraction of the liquid in the first cup is now cream? All right, so she's got 1 cup, 2 cups, and they're the same. And initially she puts 4 ounces of coffee and 4 ounces of cream. And then what she does is she will transfers half the coffee from the first cup to the second. So if there's 4 initially, she'll have to put 2 into that other cup, and that remains 2 in the first one. And then there's 4 of the cream in there. And then finally what she does is she mixes this, and then she pours half of that back into the first. So when you mix that, it becomes some mixture, but there's 6 ounces. So she's going to put 3 of those ounces back in. And then we still got the original 2 coffee in there, and this will leave 3 ounces. Now this 3 ounces is important. How much coffee and how much cream? Well, of the 3 ounces, the ratio of coffee to cream in this mixture was 2/6 is coffee. So since we have 3, it's going to be multiplied by 3. So we get 1/3 times 3, which is 1. So we have only 1 ounce of coffee. And then similarly, the other 2 ounces have to be cream. Okay? So now what they're asking at the end is what fraction of the liquid in the first cup is now cream? So if you look at this, what fraction is cream? Well, we have 2 ounces of cream, and the total is 5 because it's 3 plus 2. 5 ounces of our mixture. total. So therefore the ratio is 2 over 5, and that would mean for number 10, the answer is D.